Okay, the second workbook we're going to look at is O2A, Prepare Data, Missings. If you haven't already tried to fill in the blanks in this workbook, please pause the video now and give it a go. It's a bit of a waste if you just watch me doing this. You won't optimize your learning. I'm just going to click through the things that are already typed in for you. Unsurprisingly, we're importing OS, pandas, pickle. I'm not sure we need this pre-processing module from sklearn or matplotlib. I might delete those later, but we'll keep them for now. We need to get back from the pickle the file that we stored or that we dumped in workbook 1. So we set up the f name over here, the file name. It's in pdata, that's what we called it. And now we open that file, read binary as f, and then from f, we do simply pickle load, and we call the object which we're loading, we call it dict. If you remember, each dictionary has key value pairs in it. The key in this dictionary is dfall, and the value is the data frame dfall. So we are simply getting the data frame and storing it in dfall. Now, here we go. Create the following variable, vars underscore all, an NP array of column names. That should be familiar to you from the first workbook that we did just before. Dfall columns is going to give you the index, and we prefer to store it as an array, which we just do by calling the attribute values. Next, vardep needs to be a list. So there you are, it's in square brackets. So now it's a list, and it needs to contain the variable sale price, which it does. Variables not to use, order and PID, once again, in a list. So here we have another list with order and PID. Finally, a list of variables to use being all the variables in vars all, except vars not to use and vars dep. I hope you know list comprehensions, but just in case you don't, let's think about what a list comprehension is. It's a way of creating a list. So imagine we have a range of 10 numbers. We could do something like, for example, number for number in numbers. What will that do? Yeah, that gives us a list. Then we could say, for example, if number mod 2 is 0, in other words, it's an even number or 0 itself. Another quick example, imagine we have a list. We could create another list using a list comprehension of all the words which don't have a P in them. So we could do word for word in list if T not in word. And we just get apple and pear. So that's a list comprehension. How can we use a list comprehension to find all the variables we need here? Well, it's simply variable for variable in vars all. So that is all the variables, provided that variable not in vars not to use, plus vardep. There we go, that works. Let's just stick it where it belongs. List of the numeric variables. That is presumably going to be useful later on when we're training machine learning algorithms. Some algorithms might need to deal differently with numeric and categorical variables. Well, dfall vars ind that should say a list of all the numeric independent variables. What's the easiest way to do this? Maybe something like var for var in vars ind if the data type of this thing, which is df all var dot d type, not equal to object. If it's not equal to an object, it's more or less a numeric. I wonder if that will work. No, it did not. Should say object Now, dealing with missing data. It is a major topic. We are probably not going to talk very much about it. Let's do what we are asked. Print the number of rows and columns in the data. Well, one of the ways to do that is just df_all.shape. So there's 2,930 rows and 80 columns, just like the professor said. Find the number of missings of each feature, and we're told is null gives us missings, and you can use sum axis equals 0. So let's just do exactly that. df_all is null. That's going to tell us whether each entry is missing or not. You can see there's, for every single entry, it just tells you whether it's missing or not. And then we want to sum those missings down each column. So that means we're going to collapse axis 0. What will we get? Something like that. And we might as well store this in df missing and then just see the ones where df missing is. So that's actually a series. You should have found from above that lot frontage, garage here built, and mass veneer, masonry veneer area have a reasonable number of missings, which they do. So we're going to drop those 3 columns and remove the variables from vars ind and vars ind numeric. All right, we've already got this. Somebody very kindly typed this in for us. That would be me. Those are the 3 variables we need to drop, and we're told what to do. Use df_all.drop method. Axis 1 is the columns. In place true. The in place command means that df_all is not copied in memory from one place to another, then dropped and then put back, but it stays exactly where it is, and those 3 columns are removed. We need to remove also those variables from vars ind. Again, we'll just use a list comprehension, and likewise we can do the same for vars ind numeric, var in vars ind numeric. Rather than using a list comprehension, we could have used set differences. So we could simply have we could have turned the original vars ind, for example, into a set, and then simply done difference with the set of things we are interested in dropping. Something like that, and then turned it back into a list. Maybe that would have been neater, who knows. Now drop the remaining NAs. So we have now only 77 columns because we've dropped 3 of them, so that's as expected. And to lose the small number of remaining NAs, we had to lose 3 examples, which doesn't seem particularly problematic. I would recommend you read the original document if you haven't done that yet. He does recommend removing houses with more than 4,000 square foot. So let's do that. df_all is the whole data set, and then we will take only the subset where the greater living area is less than or equal to 4,000. We've now lost another 5 records. Run the line of code below. Note that the index for examples, or the rows, is not contiguous. Why not? 39, 40, 42, 43. You can see there's one missing over there. The reason why not is because we've just removed some of the examples, and where we removed the examples, the index was not reset. What's the advantage of leaving it like this? Well, there is an advantage, because if we ever need to compare our data back to the original data, we know that row 1341 is missing, and 1342 in our data is the same as row 1342 in the old data. But for one reason or another, I've asked you to reset the index in place. So that's what we're going to do. Finally, check that missings are no longer an issue. You can see, I think that should be SRS. I prefer to call things series if they are series, just to be neat. Finally, store everything. Let's just see what we are doing. We're creating a dictionary of the data like we did at the end of the first workbook. giving it a file name, and then opening that file, write binary, and dumping the dictionary to it. But which tends to be quite useful, we are also creating a dictionary with some information about the variables, which ones not to use, which ones are dependent, which ones are independent numeric variables, and we are storing that in a separate dictionary called O2 vars. That's it for now. See you soon.